comments and try to get to some more some issues that actually have been ignored in technical linguistic work, and when looked at, raise some very interesting questions. I'll try to say a couple of words about them to the extent that time allows. So just to start from a very general perspective, there are lots of different ways of investigating what's informally called language, but there's one that has a kind of logical priority in the sense that every approach presupposes its results, at least tacitly, even when that's hotly denied. That is the approach that considers the capacity for language of an individual person. We all have that capacity. The conclusions about that capacity arise tacitly, no matter what you're studying. Social interchange, using language, taking down a text from a tape recording or whatever it may be, from an informant. You must make some assumptions, at least tacit, about the linguistic capacity of the person. Well, the direct study of the linguistic capacity of a person is the study of what's sometimes called internal language, whatever you have in your head, eye language for short. So that concept, the study of eye language, is somehow logically presupposed by everything. And if we investigate that topic, we enter into an inquiry into language as essentially part of biology. Whatever the linguistic capacity of a person is, it's something internal to us. It's essentially a kind of an organ of the body on a par with the visual system or the immune system or some other subsystems, sometimes called modules or organs of the body, subsystems of a more complex structure which have enough internal integrity so that they can be studied in abstraction from the rest, and then you can investigate their interactions with other modules, organs of the entire organism in its life. So eye language is such a system. What is it? Well, its most elementary property is that it is the property of what's called discrete infinity. So take sentences. You can have a 5-word sentence, you can have a 6-word sentence, but you can't have a 5.5-word sentence. And it goes on indefinitely. You can have a 100-word sentence, a 10,000-word sentence, and so on. So it's like the numbers, the natural numbers. That property of discrete infinity is important, and it's from a biological point of view, it's quite unusual. You don't find it in the biological world above the level of maybe DNA. But it seems to be a unique property of human language. You find it in the number system, but that's probably an offshoot of language. There's no other system in the world that's known to have that property. Well, the general theory of discrete infinity is pretty well understood. It has been well understood since the 1940s. It's called the theory of algorithms, theory of recursive functions, various other names. And the theory of language is going to fit in there somewhere. That is, the core of an eye language is going to be some kind of an algorithm, some kind of a generative procedure that constructs an infinite array of hierarchically structured expressions, all internal to us, which are then transmitted to what are sometimes called interfaces to other systems of the cognitive system, the physical system. And there are at least 2 of these. One is the sensory motor system, because it's externalized somehow. And the other is systems of thought, planning, understanding, perception, interpretation, loosely called the semantic interface. So there's a phonetic interface and a semantic interface. Phonetic interfaces with the sensory motor system, the semantic, pragmatic interfaces with systems of thought, planning, action, and so on. And the core properties of language are that it has such a generative system, that's the I language, which essentially provides instructions to these other systems. Now, we're interested in this generative procedure in what's technically called in intention, not extension. That's intention with an S, meaning we want to know what it actually is, not just what is the class of structures that it generates. So that's study of a function in intention, and that's what we're interested in if we want to consider language as part of the biological world, because what's represented in our brain somehow is a particular algorithm, not a class of algorithms which are equivalent in the sense that they have the same category of structures that they produce. So we're interested in, so I language is individual and intentional. We're interested in its actual formulation. In this respect, it's the same as the study of any other module. We want to know how it actually works, not just the class of things it can produce. The approach to language in these terms began to take off in the early 1950s, and it's part of what's sometimes called the cognitive revolution, which actually in many ways was recapitulating a forgotten cognitive revolution that took place in the 17th and 18th century, and that was then sort of forgotten and reconstructed. So it ought to be called the second cognitive revolution in the 1950s. And the study of I language was a part of that. It helped stimulate it, it grew within it. If you study language in this way, it arose in sharp conflict with prevailing conceptions of how human thought and action should be investigated, and not just language, but everything. So the general framework of the time was what was called the behavioral sciences, behaviorism in psychology, in social science, and so on. And in linguistics, structuralist approaches, procedural approaches, methods of reducing a corpus to an organized form, and so on. That was the general conception of how language and behavior generally should be investigated. But this is a contrast. This is saying let's study it as part of biology, the way we study other biological systems, other modules of the mind, ultimately the structure of the brain. Well, if you investigate language this way, several questions arise immediately, the same ones that arise in the investigation of, say, the visual system. Roughly speaking, these are what, how, and why questions. So what are the properties of the systems of the individual I languages? Second, that's the what question. How are they acquired? So how does an infant acquire the language capacity that you and I are now using in its own particular way? And the why questions are, why does it work this way, not some other way? You can think of lots of ways in which it could happen. Why does it happen in this particular way? Those are the same kinds of questions you would ask, say, about the immune system or the visual system, and in fact are asked. Well, there are some reasonable guidelines as to how to approach these questions, guidelines that come from the very early stages of the modern scientific revolution. This is early science. We can learn a lot from the way early modern science developed. And there's some very striking features of what's often called the Galilean Revolution, the period from Galileo through Newton and beyond. One striking property of that early period was that scientists were willing to become puzzled about things that looked obvious. So for 2,000 years, it had been accepted that if an object, like say an apple, is detached from a tree, it'll fall down rather than go up. And it was taken for granted that if steam will go to the sky. So an apple will fall down and steam will go to the sky. And there was an answer for 2,000 years, the Aristotelian answer. They're going to their natural place. End of story. as long as they're going to their natural place, there's no science. Science begins when you allow yourself to be puzzled as to why they're going to their natural place. And these are the kind, and then of course you raise other questions, like was automatically assumed, it's pure common sense, that the rate of fall depends on mass. Well, if you begin to be puzzled, is that true? Why is it true? Well, it turns out it's not true. And Galileo gave an answer not on the basis of the fable about the leaning tower of Pisa, but he gave a thought experiment, pure thought experiment, from which it followed just conceptually that it can't be true. And it was very convincing. You didn't have to do an experiment. In fact, most of Galileo's experiments weren't actually conducted. A lot of them were physically impossible. They were, for the most part, sort of conceptual arguments. And so it continued. I mean, there are many things you just can't investigate experimentally, like the tides or, the motion of the planets. You can't do anything about them. But that's how modern science developed, by allowing yourself to be puzzled about what seemed like obvious things. There's another Galilean intuition which is worth bearing in mind. His conception, which then carried over to modern science, is that nature is simple. And it's the task of the scientist to prove it. So if things look complicated, you don't understand them. And try to figure out how they're really simple. That means that you have to be willing, as Galileo and his followers were, you have to be willing to put aside recalcitrant data, things that don't work. Almost nothing works. When you look at anything in the world, it's too complicated to study. But you have to sort of put that aside, even put aside what seems like conflicting data, and try to show how the conceptually correct conclusions somehow work if you understand things well enough. It's an attitude that guides research intuitions. And from small beginnings like that, tremendous enterprise, tremendously successful enterprise developed. This enterprise we call modern science. I mean, it's still the case that almost everything we look at in the world is incomprehensible, but those approaches have led very far, and it's worth bearing them in mind. Well, with regard to, say, language acquisition, the how questions, there are plainly going to be three factors involved. That's true of all cases of growth and development, the growth of the arms, growth of the visual system, whatever it may be. And we can separate these factors and try to understand them. One factor is whatever the external data is. So an infant is placed in an environment, a complex environment, booming, buzzing, confusion, as William James called it. So that's the data. Then there are internal properties. A human infant has different properties from, say, a kitten. And those internal properties, back in the 17th, 18th century, they called them instincts. We would say genetic endowment. We don't know what it is, but there's got to be some genetic endowment that's specific to the child, to the human, that enables a human infant to pick out of the complex data environment around it some information which is language related. Actually, how this is done is a total mystery, but somehow the infant instantaneously, reflexively selects out of the environment language related information. That's something to be puzzled about. It's not obvious how it's done, and in fact it's not known how it's done. It evidently involves some prosodic, rhythmic features and a few other things, but it's basically not understood. Anyway, it happens clearly, it happens very quickly. And then, almost reflexively, the child picks up the kinds of capacities that we're using. It's influenced to some extent by data, but say a Martian scientist with a different intelligence would regard all languages as essentially the same, just as we regard all bees as essentially the same when they carry out a waggle dance. Actually, if you look closely. Individual bees do it differently, but and different bee species do it differently. But for us, it's more or less the same. And it would be the same if we looked at humans from the point of view of from the perspective from which we study other organisms. So somehow or other, the child is almost reflexively picking up this capacity that we're now using. And then there's a third factor that's involved in all growth and development, and that's how natural law works. So there's no genetic instructions that tell a cell to divide into spheres rather than, say, cubes. That's just the way physical law works. And the same is true all the way through the process of growth and development. I mean, it's beginning to be partially understood in biology. It's called the Evo-Devo revolution, evolution development. In modern biology, it's pretty recent, and but finding pretty striking results. In any event, those factors have to be there. Something has to channel the course of growth and development, and incidentally also the course of evolution. Has to be channeled by more general principles, ultimately physical law. Well, these, in the case of language, it's a computational system, so a natural place to look is in principles of efficient computation. These probably hold quite generally throughout nature, but in the case of language, we want to see how they would operate, how do they interact with other factors in leading to growth and development. There's no satisfactory general theory of efficient computation, but some things are pretty obvious, like less is better than more. So a rule system, say X, is better than a rule system X plus Y, where Y has some extra rules. That's any theory of computation is going to have that property. Or minimal search is better than deeper search because it requires less computation. And there are other simple principles like that which are going to appear in any theory of efficient computation. And you can get pretty far, at least in our relatively primitive state of understanding. You can go pretty far by just appealing to simple principles of efficiency like those. Well, that's sort of the basic beginning. When you allow yourself to be puzzled and you think and you try to ask how these various factors can interact and why things turn out this way rather than others, you immediately notice right away that there's an enormous gap between the data available and the capacity attained. Now that's true in all growth and development. It's, in the case of language, it's considered controversial, but it's no more controversial than in the case of the development of the visual system. In the case of language, it's given a name only in language. It's called poverty of the stimulus, and it's considered some strange property we have to debate about. But it's a truism. The stimulus is impoverished in the sense that there's an enormous gap between the data available and the state attained. It's ubiquitous, hence also in the case of language. In the case of language, we can sharpen the question somewhat. Among the genetic capacities, we can distinguish, as a start at least, we can distinguish two types. One of them are general cognitive capacities, about which very little is known, but there are clearly general cognitive capacities that enable people, maybe other organisms, to learn things and so on. So they're general cognitive capacities. And then there are the capacities that are specific to the system of language, whatever. For example, those that enable the infant to pick out of the environment language-related information, to take the first, but much more. Those language-specific properties have been given a name, borrowing traditional usage and adapting it to a new purpose. They've been called universal grammar. Now that term has been misleading. Maybe it shouldn't have been used. It's used in this sense as just the theory of the linguistic, of the genetic component of the language faculty. That's what it is. There's a traditional usage in which it it refers to things that you find in all languages. That's quite different. Many properties of the, say, genetic component of the visual system will not be found in all visual systems because they select among them for various reasons because of the interaction of the other factors. And the same is true here. So you have to distinguish two totally separate topics. One, what are the properties you find in all languages? One sense of universal grammar. Two, what's the theory of the genetic component of the language faculty? Separate question. And I'm now talking about that. That's the theory of I-language. For theoretical linguistics, a major goal from the beginning has been to try to reduce the richness and complexity that were attributed to universal grammar. The complexity of the data and the diversity of the data that you face in the early stages, say in the 1950s, seemed to compel those investigating the topic to postulate highly rich and complex principles of universal grammar. Now, there's a problem with that. One problem is just sort of normal science. You want to have simple answers, not complex ones. You want deeper understanding rather than a superficial description. But there's another problem, and that's kind of on the borders of, maybe on the distant horizons of research. There is an empirical question. How did language evolve? Maybe a question that we can't face. Maybe we'll never be able to face it. Some evolutionary biologists believe. Dick Lewontin is one. But at least it's there. It's a real question. And that question is going to be harder to approach to the extent that universal grammar is richer. To the extent that your theory of universal grammar is rich and complex, it's going to be harder to address the questions of evolution of language. Now, it's kind of an interesting curiosity that elementary truism doesn't seem to bother people who work on evolution of language. And the reason is they're not working on evolution of language. There's there are international conferences, libraries of books and so on, all with words like evolution of language in them. And an interesting property of those is none of them deal with evolution of language. So if you take a look at a recent issue of Science magazine, the journal of the American Academy, the American Association for the Advancement of Science, there's an issue a week or two ago, which is a very enthusiastic review of a recent conference on evolution of language, talking about how much progress there's been and so on. And if you read through it, and you read through the papers of the conference, you notice that none of them have anything to do with language. I mean, they're all studies of, interesting, amusing data about what chimpanzees do and, what dolphins do and so on and so forth. But there isn't the slightest reason to believe that any of that has anything whatsoever to do with language. There's no connection. And this is overlooked because of for a number of reasons. One reason is that there's a kind of a pop Darwinism, sort of a superficial version of Darwinism, which is not biology, but is very commonly held, even unfortunately by some biologists, which hold that everything has to happen in small changes. It have to be small changes. Anything that exists has to come from a long series of small adaptations, each of which is a little different than the one before it, and they're all directed by natural selection. Well, any serious evolutionary biologist will tell you that's perfect nonsense. I mean, that's not the way evolution works. And it's understood that it's not the way it works, but that's a kind of a popular conception. And therefore, human language, following this, must arise from small steps from animal communication. There isn't any reason to believe that. In fact, there isn't even any reason to believe that human language is a communication system. In fact, there's strong reason to disbelieve it. Come back to it. But that's kind of like an a priori assumption. And it leads to some very curious results. I mean, language is a system of infinite generation. I mean, that's not questionable. And you cannot go from finite to infinite in small steps. So there's no point trying. Can't be done. You can't go from a system of maybe, say, 4-word sentences to unbounded sentences in small steps. So you have to give it up. I mean, it's not, you can't approach the question that way. Another odd property of these investigations is that they do not ask what language is. What are you trying to show? What is it that evolved? It's just, well, you know, language is used by people to talk to each other, so we'll go on from there. It's kind of like studying the evolution of the eye, when all you know about eyes is that people use them to watch television. So, okay, now let's talk about the evolution of the eye. It really is at that level. It's a highly irrational subject, and in fact, the general discussion of language is itself highly irrational. In many respects, we could go into that, but it's true. In any event, if you're serious about it, there is going to be a problem of how did language evolve someday, and you're going to have to know what it is, otherwise you can't, to the extent that you know what it is, you can ask how it evolved. And one thing that it is a system of digital infinity, hence a generative procedure, recursive procedure, and we're going to have to account for how that developed and how it works. Come back to that in a moment. There's a traditional conception of language, goes back to Aristotle, which is a common sense conception, and that is Aristotle's formula is language is sound with a meaning. Okay, it's sort of right. Now that was considered sufficient for 2,000 years, 2,500 years. If you look at the history of the study of language, which is quite rich and complex, it almost entirely is concerned with the sound part, sound in a broad sense. That includes phonology, morphology, all the ways of organizing the externalization of language, ultimately through the sensory motor system. And that's richly investigated. And it's almost the entire study of language. There's some study of meaning, or what's thought to be meaning, but it's missing something critical. The study of sound is really syntax. It's the study of symbolic manipulations inside the head until you get to the point where you attach the study to the sensory motor system. Well, that's acoustic and articulatory phonetics. That translates the phonological syntax, the morphological syntax, to actual articulatory motions, for example. Now, on the meaning side, if you want to really study semantics, there's a lot of extremely interesting work in formal semantics, which is kind of like phonology. It's talking about the parts of syntax that are oriented towards ultimate interpretation at the thought interface. But it still isn't semantics, and it won't be until it relates that to something that's mind external, just as phonology goes beyond syntax when it relates the topic to, say, articulatory motions or perceptual operations. Well, how do you relate semantics, what's called semantics, to something mind external? It's done by a dogma. The dogma is called referentialism, the belief that the elementary units of meaning, say roughly words, are related to extramental objects by a one-to-one relation. So the symbolic entity cow is related to that thing over there, which you get milk from, and so on. Now, actually, animal communication works like that. As far as anyone knows, all animal communication systems do have a referential relation between symbols and extramental entities, and you can identify them. However, if you look at human language, it isn't like that at all. There's no relation between the symbols, the words, and anything that a physicist can identify. I won't go into it, but if you begin to investigate them, you find that that's ubiquitous. There just isn't any such relationship, which means that there isn't any study of real semantics. There are books, classic books, with titles like, you know, Word and Object or Word and Thing and so on. But they're based on the referentialist myth. And if you allow yourself to be puzzled and you say, well, what is the connection? You see it just doesn't work. Now that raises a huge poverty of stimulus problem. How does anyone, how do children find out the meanings of the words, since they aren't related to extramental entities, as you find as soon as you begin to look closely? It also raises a problem about evolution. How did it ever come about? The problem about evolution is too remote even to pose. The problem about acquisition could be posed, but not until you recognize the problem. So that's a topic yet to be investigated because the problem hasn't been understood. We haven't allowed ourselves to be puzzled about the relation between, say, the word river and, you know, the Seine and so on. And when you begin to allow yourself to be puzzled about it, you find that it's quite obscure. Well, that's two of the parts of the Aristotelian slogan, sound and meaning. One aspect of it that has barely been investigated up till the 1950s is the with part. It's sound with meaning. How are they connected? Well, there was an answer to that, more or less like the objects find their natural place. The answer is it's done by analogy. So it was understood that people, you know, produce new sentences. Well, it's by analogy with the old ones. That sounds like an answer until you ask yourself, what's analogy? And then it all falls apart. There's nothing you can say about analogy. Well, again, if you allow yourself to be puzzled, the science can begin. The inquiry can begin. You can say, well, okay, how does it work? Well, back in the 1950s, as soon as this willingness to be puzzled entered consciousness, immediately it turned out that almost nothing was understood. It had been assumed at that time that just about everything was understood. There were no real problems. You just applied the methods of structural linguistics and the procedures and so on. You got all the answers. If you want to talk about language acquisition, conditioning, reinforcement, have all the answers. Turned out as soon as people started looking at it, it wasn't that everything was understood. It was that nothing was understood. Everything you looked at was a puzzle, even the simplest things. And some of those puzzles, incidentally, remain. Some of them have yet to be recognized as puzzles. I'll talk about one. One of the earliest examples that was given, there were a host of them, but there's one that kind of took on a life of its own. It's a very simple example, so I'll put it on the blackboard. Carry this. So take the sentence, say, can, it's not white, unfortunately. Can eagles swim? Okay, oh, can I use that? Can I use that? Not working.
It's not working? Yes.
Does that work? Can you hear me? No. How's that? Okay. I'll pretend I'm eating it. Okay, so take the sentence, can eagles swim? How do we understand it? Well, we're asking, the word can is actually serving two functions in the sentence. It's what's called displaced, meaning two functions. On the one hand, it's indicating that it's a yes or no question. On the other hand, it's connected with swim. Okay, you're asking about the capacity to swim. And in fact, if you look at it more closely, it's sort of semantically, it appears over here. It's related to eagles can swim, and it's saying, is it true that eagles can swim? That's the question. That also shows up in the inflectional system. not just semantically. So, for example, if I said are eagles swimming, the R would have the same relation to the inflection that it has when it appears over here. Eagles are swimming. Furthermore, the item that's displaced is actually just the inflection and whatever may happen to be attached to it. You can see that clearly in English, where you can move the inflection but not any verbal element. And when you do, you have to make up a dummy element with no semantic content, namely do, which carries the inflection. So, say, suppose it was past tense, it would be did eagles swim, and it would be related to eagles did swim, eagles swam. So this item here actually appears in two positions. It appears in the initial position where it yields the interpretation, a yes or no question, and it appears over here where it gains its inflectional properties and its semantic properties. Okay, let's call that displacement. A good question is how it works, and I'll come back to that. This alone is enough to tell us that the structures that are involved are actually some sort of a nominal phrase and an inflectional element, which is usually called T, just for tense, but it means all the inflections, and some verbal phrase that's associated with it, and these two things are related. So this is some kind of a phrase which is an inflectional phrase, and the inflectional element can go out here and give you displacement. Well, there's another property of this example which is universal. You don't pronounce both of the elements. You only pronounce one of them. And the one you pronounce is the hierarchically highest one. Okay, this whole thing is a clause of some kind, and the can is out here in what's called the complementizer position. Let's write it just as C, outside the clause, and depending on what the complementizer is, it'll be a question or an imperative or a declarative or something else. And it's the T that's raising to the C position. That ought to raise puzzles, questions. I'll come back to the questions, but they haven't been noticed. They haven't been noticed. It's just been stipulated that that's the way it works, and there are problematic elements to it. Like, for example, why does the highest, the prominent element of this thing, call it a TP, a T phrase, why is it that raises? Why doesn't the most hierarchical part of the highest part of the noun phrase raise? You wouldn't see it in this sentence, but suppose the sentence was, can smart eagles swim? Why don't you form the question by just raising eagles? So it would come out, eagles smart can swim. Why isn't that the yes or no question? I mean, it seems ridiculous, but it also seems ridiculous to say, why do apples fall down instead of up? However, it's no more ridiculous than that. And when you begin to ask the question, it turns out to be non-trivial. There's no trivial answer to why you don't raise the noun phrase and you do raise the inflection. It's been assumed, just stipulated, and it kind of has, only because it's like apples fall. It's obviously correct, so we stipulate it. But to stipulate it means to claim that it's part of universal grammar. And that means we're now posing, first of all, we're not getting a deep explanation, we're stipulating it. And secondly, we're posing just another problem for the eventual study of the evolution of language. Why did language evolve that way? After all, eagles smart can swim would be a perfectly fine way of asking a question. It's just that language doesn't work like that. So there's got to be some reason for it. And we can stipulate the reason in universal grammar, but that's not an answer. That's rephrasing the question. Well, actually, that's a poverty of stimulus problem. There was another poverty of stimulus problem which was raised since the 1950s. And that comes along when you make this a little more complicated and put in here a relative clause. So suppose it's, can eagles that fly swim. Okay, so can eagles that fly swim? Well, we know how to interpret that. The can goes with swim. It doesn't go with fly. You're not asking, is it the case that eagles that can fly swim? You're asking, is it the case that eagles that fly can swim? Well, that's puzzling, or it ought to be puzzling. It never was. You look through thousands of years of the study of language, it was never puzzling. It's just, that's the way it works. But it is puzzling. Why does it work that way? And so, for example, it would seem to make sense that extracting, that relating can to this position would be simpler than relating it to its actual position, because it's a shorter distance. You're counting less, you know. If you think of it in terms of raising, you're raising the closest element, not a more remote element. So why is that the case? Well, that's one of the earliest examples of poverty of stimulus that was discussed, and and there is an easy answer to it, or what seems like an easy answer, namely distance from the C position to the tense is closer if you measure distance structurally, not linearly. So if you just think about the structure of the construction, I won't draw it all out, the distance between the actual interpreted position and the C, the front, is minimal structurally, though maximal linearly. So it appears that language is using structural minimality, not linear minimality. That's called the principle of structure dependence. It's kind of a bad name for it, but it's basically minimal distance structurally. That seems to be the principle that language uses. Now, these properties that I've mentioned are universal. They're in every language. So you never use linear distance instead of structural distance. You never fail to pronounce the higher thing, and you never fail to not pronounce the lower thing. These are just, you always pick the inflectional element, never the main element, the nominal phrase, and so on. So everything, they show up differently in different languages, but in one way or another, these properties show up in every language and in every construction. So there's something far-reaching about them. Well, how can you go on to the why questions? So why should you use structural rather than linear distance? Well, one possible answer, the one that comes to mind right away, is that language just doesn't have counters. It doesn't have a way to count. Universal grammar doesn't have a way to count. You can't form the negation of a sentence, let's say, by taking the third word and putting it in front. It doesn't work like that. Why should language not use linear operations? Well, there could be a deep answer to that, namely the whole externalization process is just not part of language. It's a reflex of the sensory motor system. So the sensory motor system does require linear order. I mean, you can't talk in parallel. You have to talk in time. So it imposes linear order. And therefore, it would make sense to think that the process of going from the internally generated structures to the sensory motor system add order along the way. Okay, they would require order because the sensory motor system does. Well, that conclusion is fortified by the observation, apparently correct observation, that semantic interpretation doesn't require linear order. It requires hierarchy, but not linear order. Now, that's contested and debated, but it seems to be pretty well confirmed. Well, if that's the case, then there would be no reason for the I language, for the generative procedure, to impose linear order on the path to the thought system, okay? Only on the path to the sensory motor system. So therefore, if that's correct, then linear order would not even be available for these operations. It wouldn't be there. So the question of linear closeness would never arise. Well, that looks like a good answer. There's some problems with it. One problem is that there appears to be empirical evidence that Syntax, though not semantics, does require linear order. Okay, now we're in the Galilean conundrum. There's an answer that ought to be true, just on conceptual grounds, and there's empirical data which seems to conflict with it. So we get conflicting research intuitions. No point arguing about them. We could just identify them. One is the Galilean intuition. The data aren't understood. So let's proceed to understand the data and show that really order is imposed by the sensory motor system. The other is to say, well, I'm stuck with the data, so we'll throw out the natural conclusion. You just have to pick your own research intuition at that point. My own is, as you can guess, the first. I don't like data. But that's a common situation in the sciences all throughout, and here too. There may be another answer to this, which doesn't involve this principle. I'll come back to it in a minute. Even if we do accept this, it still leaves the first question. Why is the displaced element the inflection and not the noun? Still leaves that question. Well, in order to, actually I should say on the side that I mentioned before that almost all the investigation of language, like 99%, has been externalization. It's been morphology, phonology, linear order, things like that. And that makes good sense. That's the data that's immediately visible. You can see it, You see the phonetic, you hear the phonetics, the order, and so on. It's also the domain in which languages appear to vary. There's a lot of variation in externalization. It's highly subject to historical accident. So it's the area of language that changes very quickly. So you have the Norman invasion, you start pronouncing things differently and so on, different words and so on. It's also, it's the hard problem of acquisition. So if you're trying to learn a second language, you have to learn the phonetics, the morphology, the inflectional systems, the order of the words, and so on and so forth. You don't learn the semantics, and you don't learn the syntax. In fact, if you had to learn them, you'd never learn the language, because nobody can teach them. Nobody knows what they are. Those things are somehow just come automatically. And those also seem to be the parts of language that are pretty much invariant. To the extent that we understand them, they're essentially invariant. Maybe totally invariant if we understood enough. But the variation and the complexity is overwhelmingly in the externalization process. Well, all of that, once again, suggests, and there's stronger reasons for it, that the externalization problem is probably ancillary to language. It's a secondary process. It's a secondary development. There is the language, the I language, the semantics, the relation to the thought system, kind of a language of thought, if you like. And then tacked on somehow is externalization. And it's a difficult problem. You have to, the sensory, if you think about it from an evolutionary point of view, we don't know much about the evolution of language, but a few things are pretty clear. One is that language evolved pretty recently. So there's no evidence for it in the archaeological record up to maybe 100,000 years ago or something like that. After that, there's a kind of a burst of creative activity that shows up in the archaeological record. Complex symbolic representation in the arts and the representation of astronomical events, complex social structures. Also, it's sometimes called the Great Leap Forward. There's a huge increase in sort of creative imagination that shows up in the archaeological record, and it's generally assumed by paleoanthropologists pretty plausibly that that's related to the evolution of language. The evolution of language gave the capacity to think and to do all kinds of things. So probably around that time, maybe somewhere around 100,000 to 50,000 years ago, it doesn't, exact dates don't matter, but sometime around then, language evolved. Well, what had to evolve was the operation that produced digital infinity. There can't be any precursors to that. As I mentioned, there can't be precursors. It's just like the number system. either you have it all or you don't have any of it. There are no precursors. There's a lot of talk about proto-language and so on. There's no empirical evidence for it, no conceptual reason for it. It's just mythology. So something happened around that time which yielded the capacity for infinite generation. Well, it had to be a mutation of some kind, maybe a small mutation which rewired the brain somehow to give this process. Mutations take place in an individual, not in a group. So it happened to some person. There's a couple of marginal exceptions to this, but we can put them aside. Like a mutation in a germ cell could have hit many individuals. But basically, it takes a mutation is something that a person undergoes. Now, that person would have had the capacity for thought. It would have a capacity for infinite generation of hierarchical structures, which relate to whatever conceptual apparatus was around prior to that, the thought system, a mystery. But that's the other mystery I mentioned. However, there would be no point in trying to externalize it, because nobody else has the capacity. Okay, so it's inside. Well, you know, such a mutation could have selective advantages. It's not obvious, but it could at least. And it would be transmitted partially to offspring. If there are real selectional advantages, it could take over a small breeding group. Our ancestors were very small in number, maybe thousands. At that